Engines are everywhere. They power our cars, motorcycles, boats, and even lawnmowers. Engines make our lives easier and more fun, but how do these mechanical marvels actually work? Engines come in many shapes and sizes, but most fall into two main categories: four-stroke and two-stroke. Understanding the difference between these two engine types is key to appreciating the inner workings of the machines we rely on every day. Four-stroke and two-stroke engines both use a controlled explosion of fuel to create power. This power then turns a crankshaft, which ultimately drives the wheels of a vehicle or the blades of a lawnmower. The key difference lies in how these engines achieve this process. A four-stroke engine, as its name suggests, completes its power cycle in four distinct strokes of the piston. On the other hand, a two-stroke engine accomplishes the same goal in just two strokes. This difference in operation leads to unique characteristics for each engine type. Imagine a cylinder with a piston moving up and down. This simple motion is the heart of an engine, a symphony of mechanical precision and power. The four-stroke cycle begins with the intake stroke. During this phase, the intake valve opens and the piston moves down, creating a vacuum that draws in a mixture of fuel and air. The piston moves down, drawing in a mixture of fuel and air. This mixture is essential for the engine's power, as it will soon be ignited to produce energy. Next comes the compression stroke, where the piston moves up, squeezing this mixture tightly. This compression increases the mixture's potential energy, making it ready for ignition. At the top of this stroke, a spark ignites the fuel-air mixture, forcing the piston back down during the power stroke. This is where the engine generates its power, converting chemical energy into mechanical motion. Finally, the exhaust stroke sees the piston moving up again, pushing the burnt gases out of the cylinder. The exhaust valve opens, allowing these gases to escape, clearing the way for a fresh charge of fuel and air. This completes one cycle, and the process repeats. Each cycle is a seamless blend of precision and power, driving the engine forward stroke by stroke. Section 4, the two-stroke tango power in every revolution. In this section, we delve into the fascinating mechanics of the two-stroke engine, a marvel of engineering that delivers power with every revolution. The two-stroke engine takes a more streamlined approach compared to its four-stroke counterpart. It is designed to complete a power cycle with just two movements of the piston, making it incredibly efficient and powerful. Imagine the same cylinder and piston, but with ports or openings in the cylinder wall. These ports play a crucial role in the engine's operation, allowing for the intake of fresh fuel and the expulsion of exhaust gases. As the piston moves up, it compresses the fuel-air mixture. This upward motion is essential for preparing the mixture for ignition, ensuring that the engine runs smoothly and efficiently. Near the top of this stroke, the spark plug ignites the mixture, pushing the piston down with a powerful force. This ignition is what generates the engine's power, driving the piston back down. As the piston descends, it uncovers the exhaust port, allowing burnt gases to escape. This step is vital for clearing the cylinder of exhaust, making room for the next charge of fuel and air. Simultaneously, the downward piston motion uncovers the intake port, drawing in a fresh fuel-air charge. This fresh charge is essential for the next cycle, ensuring that the engine continues to run efficiently. This completes one cycle in just two strokes. The simplicity and efficiency of this design make the two-stroke engine a powerful and reliable choice for many applications, from motorcycles to lawnmowers. Section 5. Comparing the Contenders four-stroke versus two-stroke. In this section, we will delve into the fundamental differences between these two types of engines, exploring their unique characteristics and applications. The difference in their operating cycles gives four-stroke and two-stroke engines distinct personalities. Each type of engine has its own set of advantages and disadvantages, making them suitable for different purposes and preferences. Four-stroke engines, with their separate strokes for intake, compression, power and exhaust, are generally more fuel efficient and produce fewer emissions. This efficiency is due to the fact that each stroke is dedicated to a specific part of the combustion process, allowing for more precise control over fuel and air intake. They also tend to be more durable and require less frequent maintenance. The design of four-stroke engines often includes more robust components, which contribute to their longevity and reliability over time. Two-stroke engines, on the other hand, are known for their simplicity, lighter weight, and higher power-to-weight ratio. This makes them ideal for applications where space and weight are critical factors, such as in handheld tools and small vehicles. They pack a punch for their size, making them suitable for applications where power and portability are paramount. The simplicity of their design also means they can be more cost-effective to produce and repair. However, they typically consume more fuel, produce more emissions, and require more frequent maintenance than their four-stroke counterparts. This is due to the fact that two-stroke engines complete a power cycle with every revolution, leading to higher fuel consumption and increased wear on engine components.